So this is lecture 31, question 6, and it reads the following questions to a point pertain to a 0.58 molar solution of benzoic acid HC7H5O2 at 25 degrees Celsius, and the Ka is equal to 6.4 times 10 to the negative 5. 10 to the negative 5. Okay, so to begin with, we will put the solution into water. So it would be HC7H5O2 aqueous plus H2O liquid equal to H3O. Since this acid is a strong acid, so it dissociates completely, so the H is taken off and it's added to the H2O to create H3O. And because of that, the conjugate base, it would be C7H5O2 aqueous, and H3O is also aqueous. So to begin with, for part A, we know in order to find the concentration of H3O, we would need to put this equation into an ice chart. So it would be the reactants, which is HC7H5O2, and the product, H3O and C7H5O2. Notice how we didn't put the H2O into the ice chart, mostly because it's a liquid, and for ice charts we only do aqueous solution, so there's no liquid or solids in an ice chart. So to begin with, for the initial concentration for HC7H5O2, it tells us that there are 0.58 molar solution, and H3O will be 0 and C7H5O2 will be 0, mainly because it's on the product side and the reaction did not take place yet. So for the change for HC7H5O2, it will be negative X, since the reactants is going to the product side to create, well, the products, and H3O would be plus X, and C7H5O2 would be X. So for the ending, we would just add the H and the C together. So it'll be 0.58 minus X, X, and X. So in order to find X, we would have to plug it in. We have to plug into the equation of Ka equals products over reactants. So in the question, it tells us that the Ka is 6.4 times 10 to the negative 5. And we will equal it to the products, which is X times X over 0.58 minus X. But according to the 5% rule, which is if the Ka is less than 1 times 10 to the negative 4, the X for the reactant side, the change is so negligible that the X doesn't really, that we don't really need to focus on the X for this equation, since the change is so little we won't really exactly notice it. So we would do cross multiplying from this point. So 6.4 times 10 to the negative 5 times 0.58 is 3.712 times 10 to the negative 5. And that is equal to X squared. So in order to get rid of the square, we will square root it, and the X would equal to 0.006. So with the X here, we would plug it in to this X to find the concentration of H3O plus, which is 0.006. So this is the answer for part A. Now for part B, it says find the pH of the solution. So we know in order to convert the concentration of H3O plus to pH, we will plug it into the equation of negative log times the concentration of H3O plus. So we will plug it in. So negative log of the concentration, which we found in part A, is 0.006. So we will plug that into the calculator, and we will get the end result of 2.22 if we round it up to sig figs. And this is our answer.